to you today to give back to your parents, and I forgot to bring it. Oh well. I'll try to remember to bring it on Tuesday.
Okay.
I texted your mom last night because I texted her something else, and then I was like, oh, do you want me to send this with Tristan? She was like, sure, and then I forgot to pack it. Whoops. Okay, so sometimes, this is going to be like one little sentence note here. We write df, which is really f prime of x dx, where df is the differential of f. So really, that's just more so explaining what we've already been doing, just the notation, but it'll help us a little bit with this next part here. So these are all like short little like one sentence. They're kind of written like a word problem. But basically they say write a differential formula that estimates the given change in volume or surface area, then use the formula to estimate the change when the independent variable, which would normally be x, but in our particular situation it may or may not be, but changes from 10 centimeters to 10.05 centimeters. And so 32, we have surface area. It says the change in surface area, S equals 4 pi r squared of a sphere, when the radius changes from A to A plus dr. So what that's telling me is that basically r is going to be my independent variable, like what normally would be my x. And I mean, that kind of makes sense in this particular problem because obviously r is the only variable on the right side. But all I'm doing initially is taking the derivative, but I'm going to specify because it's not just like x and y. I'm not just going to write like s prime. I'm going to write ds, and then I'm going to use dr on the other side. Kind of the way we ended up with these ones yesterday, where I was taking the derivative and then I was writing the dx for the differential, because that's where the difference from the 10 to the 10.05 centimeters from the instructions is going to be basically going in. So derivative of this would be ds is equal to 8 pi r dr. It's almost like when we did the implicit differentiation where it was like y prime. That's like kind of what this is. And, you know, anyways. So then now dr is 10.05 minus 10, which is the 0.05. I probably won't show that step in the remaining problems because they all use the same dr value because of the instructions. But anyways. So now I'm going to plug in A is 10, and then the A plus dr, or well, the dr part in this particular problem is the 0.05. So ds is equal to 8 times pi times r is 10 times dr is 0.05. And I don't really know why per se, but they actually leave the answer as 4 pi and then its area, so centimeters squared. If you multiplied the pi through, that would also be totally fine, but the book is leaving the answers in terms of pi. I'm guessing they're doing that because essentially if this was a non-calculator question, they wouldn't be expecting you to multiply it through, so I'm guessing that's why, but again, up to you. 36. The change in the lateral surface area, S equals 2 pi RH, of a right circular cylinder when the height changes from A to A plus DH, and the radius does not change. So again, from the instructions, A is going to be 10, DH is going to be that 0.05. Now, something that's really critical to pay attention to here is the fact that it says radius does not change. That means the radius is a constant value. So I'm not treating R and H both as variables. The only thing that's a variable is H. So I've got ds is equal to 2 pi r times the derivative of H is just dH. So in this particular problem, our A value, or what would be our H, isn't irrelevant because when I took the derivative, it went away. So I essentially don't even need the 10. So I've got ds is equal to 2 pi times the radius. Did they tell me what radius was? I do not think so. Yeah, they don't tell me what radius is. They just tell me that it stays constant. So I'm just going to leave it as R. And then times 0.05. And I think 2 times 0.05, yep, is 0.1. So then we would just say that this is 0.01 pi r centimeters squared for my surface area there. The next set of problems here say to, yes.
Would it be 0.1 pi r, or is it 0.01?
It is 0.1.
Okay.
I don't know why I put a 0 there, but you know, minor details. Mama. All right, the next little set of problems say to use differentials to estimate the maximum error in measurement resulting from the tolerance of error in the independent variable. Express answers to the nearest tenth, since that is the precision used to express the tolerance. So essentially, that's what they're using as like their significant figures, basically, is to the nearest tenth for the relativity of this. So number 38 says the volume of a sphere with radius 8 plus or minus 0.3 inches. So on these ones, this is where you may have to refresh on some of your like volume and surface area formulas. These are formulas that they will expect you, if you had a question like this on the exam, they expect you to know the formulas of things like a cylinder, a sphere, a cone, obviously like a box. That one's probably pretty obvious. So I would just make sure at some point that like you refresh on those. Obviously right now you can look them up or whatever, but just before the exam, I'd make sure you refresh on those. Those are kind of the most common ones I would say that they're going to use. So volume of a sphere, do you happen to know what that formula is? If not, it's okay.
Is it like pi r cubed?
You're very close. There is a 4/3 in front of that, but it is pi r cubed. And through obviously this problem or this section has a couple of these, but the next section we'll be dealing a lot with cones especially. So we'll kind of refresh on that formula when we get to that point as well. So I need to take the derivative like I was doing in the previous problems. So we've got dv equals, well, when I take the derivative, 3 is going in front, so I've got 4 pi r squared, and then that dr there. So the 8 is my radius, the 0.3 is my dr. So I have 4 pi times 8 squared times 0.3. And on these ones, they do multiply the pi through, you know, or I think they do. Yeah, they do. So, but again, I wouldn't care if you leave it as pi or you multiply it through. I'm good with whatever. So when I do that, I get 241.3, because he said to 1 decimal place, and that is in inches, so inches cubed.
For the ones like 36 and 32, we were solving for area, right?
Yeah, that was surface area.
Okay.
Yeah, if there's like a capital S, it's surface area. And the problem said that, I just didn't write all of that down.
I just wanted to make sure, because I just was like, wait, where's the square?
There are, so it's kind of funny because basically in that section, the odd ones are volume and the even ones were area in 31 through 36. I get really irritated when they do that because I'm like, most teachers don't assign random problems. They either assign odds or they assign evens, but whatever. Teachers don't usually write textbooks, but the only thing that will change in those problems, because obviously you'll have a couple odd ones, is that the units are going to be cubed instead of squared.
Okay.
So. So another like place where this stuff comes in as more of a practicality problem is if you are thinking about like say like a balloon, but obviously it would have to be like a circular balloon. Like a normal balloon obviously is, you know, has a weird shape. But anyways, we're going to look at expanding a circle, so basically making a circle larger instead, but you'd kind of use that same process if you were doing it for like the difference in like a balloon. And that stuff will kind of come up a little bit in the next section as well. That we'll be doing more so with like the shapes, but this is kind of like leading into that. So 42, it says the radius of a circle is increased from 2 to 2.02 meters. My brain was still on balloon, and I was like, that is a ginormous balloon. And I was like, oh, wait, it's just a circle. And this has 2 parts. So part A says to estimate the resulting change in area. And then I'll write part B after we do this. So area of a circle is pi r squared. We know that the radius is like your initial value. So r is going to be equal to 2, and dr is the difference between those two things. So that's going to be 0.02. So then now I can take this formula and find the derivative. So we've got dA equals 2 pi r dr. And then we just need to plug the stuff in. So 2 pi times 2 times 0.02. And on this one, they give you the answer both ways. So times 0.02. So 0.08 pi. And that is equal to 0.251 as a decimal, if you were so inclined. So then part B says estimate as a percentage of the circle's original area. So no derivative here other than that we're using the value that we just found from the previous derivative. So basically to find this, we're going to have dA over A, so the original area, times 100 to give us our percent. So I'm going to use the 0.08 pi because the original formula has a pi in it, so they'll cancel. That's probably why they wrote the answer both ways now that I'm thinking about it. And so then over pi times r squared, so I'm just going to write it as 4 pi. And then all times 100. So pi's cancel, 0.08 divided by 4 times 100. And when I'm done with that, that ends up giving me 2%. So basically, the change in area is essentially a 2% difference from the original area. So, not too bad. Any questions on those ones? Okay. So, problems then. Let me find... Oh, there they are. Since there's kind of a variety in here, it's going to seem like a lot, but like I said, if you don't finish them today, you can do them on Tuesday. It's fine. 1, 5, 9. I would say just do like A and B. I wouldn't even worry about all of them because those are those ones that are like super weird about just like how to rewrite them. 13, 15, 17, 23, 25. 25, you may need to review your derivatives of inverse trig because that's an inverse trig question. And then 31, 35, and 39.